To determine the ampacity of busbars according to the National Electrical Code, refer to section 368.704. This section provides specific guidelines for calculating the allowable current carrying capacity of busbars used in electrical systems. Busbars are conductive bars typically made of copper or aluminum, and they serve as a common connection point for multiple circuits. Accurately determining their ampacity is crucial to ensure safe and reliable operation, preventing overheating and potential fire hazards. Several factors influence the ampacity of a busbar, including its material, cross-sectional area, ambient temperature, and cooling methods. Copper busbars generally have a higher ampacity than aluminum busbars of the same size due to copper's superior conductivity. The larger the cross-sectional area of the busbar, the greater its ability to dissipate heat and carry current. Higher ambient temperatures reduce the ampacity of a busbar, as the heat generated by the current flow is more difficult to dissipate. Effective cooling methods, such as forced air or liquid cooling, can significantly increase the ampacity of a busbar. Section 368.704 outlines the specific procedures for calculating busbar ampacity, taking into account these factors. It refers to other relevant sections of the NEC for detailed information on conductor ampacity adjustments and corrections for ambient temperature and the number of conductors. The calculations typically involve determining the base ampacity of the busbar based on its material and cross-sectional area, then applying adjustment factors for ambient temperature and the number of conductors. These adjustment factors account for the reduced heat dissipation capacity under different environmental conditions. In addition to the calculations outlined in section 368.704, it's essential to consider the specific application and installation requirements of the busbar. The busbar should be properly supported and insulated to prevent accidental contact and ensure safe operation. The connections to the busbar should be properly tightened to minimize resistance and prevent overheating. Furthermore, it is important to consult with a qualified electrical engineer or inspector to ensure that the busbar installation complies with all applicable codes and regulations. The NEC provides comprehensive guidelines for electrical installations, but it is not a substitute for professional expertise. Proper busbar ampacity calculation and installation are essential for ensuring the safety and reliability of electrical systems. Overloading busbars can lead to overheating, insulation breakdown, and even fire hazards. By following the guidelines outlined in section 368.704 and consulting with qualified professionals, you can ensure that your busbar installations are safe and compliant with all applicable codes and regulations. Remember to always prioritize safety when working with electrical systems. Firstly, always energize the circuit before working on any electrical components. Secondly, use appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, follow all applicable codes and regulations. By taking these precautions, you can minimize the risk of electrical shock and other hazards. Understanding the factors that influence busbar ampacity and following the calculation procedures outlined in the NEC are crucial for ensuring the safe and reliable operation of electrical systems. This knowledge empowers you to make informed decisions about busbar selection, installation, and maintenance, ultimately contributing to a safer and more efficient electrical infrastructure. The NEC is a comprehensive document, and it is essential to stay updated with the latest revisions and amendments. Electrical codes are constantly evolving to reflect advancements in technology and improvements in safety practices. Regularly reviewing the NEC and attending relevant training courses can help you stay informed about the latest requirements and best practices. In summary, determining busbar ampacity requires careful consideration of several factors, including material, cross-sectional area, ambient temperature, and cooling methods. Section 368.704 of the NEC provides specific guidance for calculating busbar ampacity, taking into account these factors. By following these guidelines and consulting with qualified professionals, you can ensure that your busbar installations are safe, reliable, and compliant with all applicable codes and regulations. Remember to prioritize safety when working with electrical systems and stay updated with the latest revisions of the NEC. Proper busbar ampacity calculation and installation are essential for preventing overheating, insulation breakdown, and fire hazards, ultimately contributing to a safer and more efficient electrical infrastructure.